We're here to talk through this gapped Kakuro puzzle from Serkan. Like many gapped Kakuro, actually the key clues are often the smallest ones. Small digits is 2 stands out to me at the start. A 2 has to be a single digit. There are 3 potential cells and we can't have empty cells next to each other, so placing that in the middle leaps out. But a different place, actually 3 places, somewhat symmetrically, this 10, this 12, this 11, somewhat low as sums. Any sum that's below 15 can only use 4 digits, and when you have 9 in a row or in a column, to be able to place 4 digits, they have to be spread like this, with 5 unused alternating with the 4 used. You'll actually see that you can mark the same in this row, and the same down here. And depending on how you choose to mark, I find it helpful to indicate where I know I'm going to include digits with circles typically, so just mark these all. In this case, we actually know the digit will go there. It's the only number left to fulfill that whole clue. The next step probably from here is to think about some associated cells that need to be filled. That needs to be filled. A 10 is going to use digits as large as 4, so we'll have to be a digit below here. We now have a situation 21 has 6 cells filled in as containing digits. It can't take 7 to have a 28 or higher sum. You can use 7 digits, but 21 is requiring just 6, so we can get actually that placed into the grid. You can do similar thinking in this order, so to use 6 digits you need a sum of 21, the sum is 18, so this is not used. But in the same way, if we take the largest numbers, 9 plus 8 plus 7 plus 6 plus 5, 35 is the largest value that a sum of 6 can use. Sorry, 5 digits can use, so we need a 6 digit, which goes there. We can look at this 15. 15 can have at most 5 digits, 4 are already given. We have lots of blank space, so the 5th digit sits there. And then 18 can be 4 or 5 digits, so we can't do much more there. 35 can be either 5, 6, or 7 digits. Can't do much there yet. So we've got to shift back to Kakuro solving for a bit of time. A lot of these clues have multiple options. The one that really only has a pair of options is a 16, which can be 7 on the left or 7 on the right, paired with a 9. And 18 can have as largest digits as an 8, which will leave behind 1 plus 2 plus 3 plus 4. So if a 9 were actually here, you couldn't fill in the whole column. So the first real breaking point is there. This leaves behind 11 and 4 cells, which is 1, 2, 3, and 5. So I'll just go through and mark the possibilities. With a 5 already here, 1, 2, 3 is up there. 1, 2, 3 can sit here because if a 5 sit there, we couldn't fulfill the whole clue. That would pair with a 2, 3, 4. This as well can be a 1, 2, 3. Actually, a 1 will put a 9 in, so this can be a 2, 3, but it can't be a 5. A 5 would put another 5 here and repeat a digit. So the only place a 5 can go in this column is down there. We can now sort of go a different direction. We can mark this cell can be a 1 or a 3. This cell can't be a 3 because 3 plus 3 would repeat a digit. It also can't be a 1 now that we've placed this digit, so it has to be a 2. Or else you repeat a digit in this row. We now have 2 digits in this 21, which will help us out. We need a very large digit to be able to add into the sum. The only option left is a 6. The next largest, which is 3, is going to be too small to get what we need to happen. And we'll put in the options again. Now we have, as we're filling in the options for this 11 coming down, this cell can be a 1 or 5, it can't be a 3, again you'd repeat a digit, and this cell can be both. We have a situation we have to fulfill this leftmost column. Right now we have 3 cells that look like they're going to be rather small, and in particular I guess we can chip away at this in various orders, but the first is say like if this is a 1 and then these rest are all below 5, typically if this is 1 we leave 35 behind, we need 5 and above. So need to have a 5 in there. But even with a 5 in there, the largest the remaining cells can add up to is 7. 7 with 5 is 12, leaving behind 24. 24 is a pretty common sum. You'll recognize that as 9 plus 8 plus 7. And so anything smaller than these adding up to 12, that is to say this having the largest digit possible and this having, for its sake, the largest digit possible, that's going to cause an issue for filling in the rest of the grid. So we can quickly progress to this point. Placing this as a 1, we'll actually finish off this area well. We can actually come up here and finish off this area. 12 is an interesting kind of 4-digit sum. It has two options. It'll always use a 1 and 2. It'll then have a 3 was a 6 or a 4 or a 5. Once you place a 5, we know the remaining digits in this row are 1, 2, 4. This is the one that's most constrained because it needs to have the largest option. We now have a 1, 2 left over, but this 1 sort of feeds nicely like Latin squares, canceling out options. We actually have 1 and 2 filled here, so the smallest digit remaining is a 3. That will actually close out this sum. A 6 could have this cell used, but if 3 digits were included, we need a 1, 2, or 3 in that space, and those aren't options anymore. So we get to a spot like here. The leftovers of this column are an 8 and a 7. Placing this 8 gives us that. This gives us a 2. Gives us a 3 up top. Let's do math and try to come across. So we have 27 used, so we're left with 8 to go. 8 is sometimes 1 with 2 numbers, but that'd be 2, 5, 3, 4. It's not going to work. So this looks like it has to be 2 of 6. That means this cell isn't used. And in particular, the largest digit in a 15 and 5 is the number 5. So the 2 is on the left, the 6 is on the right. With this 2 on the left, we can actually clear out the bottommost space now. Only options to go there. This cell can't be a 3, it could be a 4, 5, which will leave behind. Actually, it can't be a 4 either because of this 2, it has to be the 5. Gets us to this. We now have to think about this 8 sum. And 8 can work in 3 digits, but if it did, it would have to have a 1 because you'll see that the 1 cells are all filled in that column. This ends up needing to be a 2-digit sum. It can't have a 1 and it can't have a 2 in it, so it's going to have to be 3 with 5. This is the only option for it. It gives us this 4. It's going to need another cell to fill out the sum. This is going to be a 4 with a 5. If this is a 4, that would be an 8. If this is a 5, that would be a 7. And the last deduction is going to come from seeing that in the 2 options here, the 2 is already canceled. So the only way that this cell fills is for it to be a 3. Makes that a 7. Makes this a 5. And makes that a 1 when we get through the puzzle. So it's pretty fun if you're actually used to a lot of the Kakuro rules, particularly if you're used to these kinds of sums. Once you get the basic pattern of the gapped Kakuro empty cells, it's a lot of just simple pattern matching, but you see a pretty narrow path to get around the grid, and you almost certainly end on the side after working at the start mostly on this left side. So an enjoyable Kakuro puzzle. You'll have a treat coming in the future with more Kakuro on the website and also some ebooks before the end of the year. So I think we'll maybe have some more walkthroughs of this type in the future. We'll see you again soon.